This is a custom board I designed. And today I'm going to try to bring up all the peripherals using completely nothing but AI. And no, I'm not going to use Arduino. I'm going to use the ESP IDEA framework. I'm going to let AI write the code, test it on real hardware, and see how far it gets. Because a lot of the embedded systems engineers I talk with on a daily basis say AI is simply not there. So I want to put this theory to the test. Can AI program and bring this board up without me writing a single line of code? Well, let's find out. Here's the schematic. We've got an ESP32. We've got capacitive sense buttons that are attached. We've got a chain of RGB addressable RGB LEDs. We're talking to the device via just a USB here. So we're talking native USB on board. And we've got a piezo attached to one of the pins here. The goal is to simply bring up this board, meaning get the LEDs working, get the piezo working, get the capacitive touch working, right? And then see if we can actually go any further from that. To be honest, if we're able to bring up just the peripherals, that is already pretty scary. Because think about it, bringing up the microcontroller at the lowest level is actually pretty difficult. It requires knowledge of the chip, requires knowledge of the SDK that you're using, right? In this case, we're using the IDF framework. I don't know. But to establish a baseline, we will simply program in a hello world example onto this board. I really want to see that the controller is running, just to make sure we're not headed any further than we need to in step one. Once we establish that the controller is running and we're able to get the basics out of it, that's when we'll just simply copy the project and get it into Cursor. And while this is compiling, I do want to say this. My idea for this board is to have multiple modes. I want to have a piano mode and I want to have two different game modes. All right, exciting. We are compiled. Okay, here we go. The chip is actually running. Hello world. This is an S3 with 2 CPU cores, Wi-Fi, blah, blah, blah. Everything looks good. Cursor is now open in the directory that we just created. We've got just the hello world here and we can actually browse the firmware just to confirm. This is literally all there is. This is, again, just a standard hello world that comes directly with, as an example, with IDF, which is great. Let's do some magic. And as I'm editing this video, I just realized I never mentioned why I am even pursuing this experiment. Well, one of the reasons is because people have been emailing me. They've been making modifications and customizations to the firmware, to my open source project, to my open source product, I should say. People have been writing their own custom firmware, they've been doing their own dashboards, and that is all thanks to AI. And that's actually one of the reasons I do believe open sourced hardware and firmware will do extremely well in the coming years. Well, this cube just turned red because I'm talking and blowing air at it. This is, by the way, a VOC sensor and temperature sensor and a humidity sensor. It checks your air and it tells you if your air quality is good or bad. Anyway, back to the video. Now, let's take a screenshot from the schematic. We will upload this screenshot directly into Cursor and tell it, hey, look, we've got capacitive touch buttons, we've got our RGB LEDs, we've got the piezo, right? Map out the pins and let's see what happens. Okay, so the first thing I'm going to do is I'm going to tell AI, in this case, we are using ChatGPT, basically GPT 5.3 codecs, right? We're going to upload the schematic and tell it to, hey, give me and extract the labels, or rather the pin numbers that our capacitive touch corresponds to, and addressable LEDs and the piezo, right? So it should be fairly simple, but again, AI sucks at processing images. So let's see what happens. What I literally had to do by hand is pin out the whole thing for the AI. We'll see if that even works after, but I'm giving it the entire map, basically, of our I/O. It was not able to read the schematic. And to be honest, that's one of the things I noticed AI really sucks at. But the question is it going to be able to actually write the code and bring up these peripherals. Capacitive touch, RGB addressable LEDs, that's going to be probably a tough one, right? Because that requires writing timing and custom logic and all that sort of stuff. Then the piezo as well, because we have to output a wave to the piezo. It's not, I don't want it to be just a simple on and off. I want it to actually play frequencies. Okay, now instead of doing an ask, we're actually going to start planning. Okay, so let's bring up the capacitive touch. This is literally what I'm telling the AI to do. And I'm saying this will be the only task we will plan for at this step. So the point is, I'm trying to reduce the load at once, right? Because AI has a context window, and those context windows, well, they are fairly, to be honest, small for big tasks. Maybe you could have done all of it at once. I kind of don't think so. Maybe I should try. But let's try to give it some slack, and we will bring up the literally just the capacitive sense first. So that way, we are able to press these buttons, and we're able to get a console serial output. Well, let's see if we're able to actually achieve even that. Okay, it's asking me a question. All right, cool. Which timing should define short versus long? Yeah, I think 700 milliseconds for short, and then long, I think that's fine. How should the long press behave? Log long once the threshold is reached, wait for the release. Oh, that's actually interesting. Okay, so this is actually cool because it's actually asking me questions about the behavior of the buttons. It's not trying to assume anything, which is nice. I like that because that way you don't get random output that you did not expect. This is pretty cool. Okay, let's go for the first one here. Okay, so it's built us a plan, right? It's going to pin the map correctly now. Nice, because it's following my directions. What I do like about this is actually you can correct it, right? Basically, we want to say, hey, this is a hello world. You can erase everything within the hello world. So it should update the actual plan before doing anything, because then I have to press build. Okay, so it actually did quite a bit of code without me pressing build. Hey, cursor, that's a bug. Okay, but let's see what it actually did. All right, so in main, now we have an actual delay, which is great. That means we're not going to restart like before. Initialization, do not touch pads during startup calibration. All right, calibrate touch, ready, and then it goes into a loop. Cool, all right. And then these are the actual touch inputs and so forth. So it did not create a separate file for this, but that's okay. It's actually fairly small. That's not great coding per se, but at the same time, I did not specify for it to go out and actually make new files. So that's okay. Let's see if it actually works. All right. So yeah, here's our review, basically. We've gotten a bunch of new stuff, and then all of the hello world and stuff has been erased. Let's bring up the console and see if it actually compiles. It did not build, and here is why. It does not know this directory at all. All right, cool. I'm going to give it I'm going to switch to agent mode. I'm going to give it the error and see if it figures it out. All right, so far, to be honest, not as smooth as I was hoping for. But if we do get this to work, I mean, to be honest, bringing up just a capacitive touch by hand is hours of work. If we could skip some of it, and if we could tell the AI, hey, look, put it into its own files and, do this whole thing. Hey, I mean, it could be a big time saver. Okay, it says it fixed the root cause. It failed again. Oh, come on. Nice. We are built. Okay, but is it going to run? Is it going to run? Not touching the board. Let it flash and it has to calibrate. All right, baselines. Capacitive touch calibrated? No way. Okay. I need to, hold on. Wait, how do I do this? Let me point the camera down. Okay, I'm actually excited. This is cool. All right, capacitive touch 1. Press. Really? Nothing. So it's not reacting to any touch right now. I had high hopes that it would work on literally trial 1, but That's not the case yet, at least. All right, what it changed? Fixed raw threshold detection, blah, blah, blah. One more time. Oh, 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 oh. It actually did something. Hey, look, if I'm pressing the button, you could see that there is a change, or rather it's detecting something, but it's not correct still. I wonder if, well, let's just copy this over and tell it what happened. I wonder if there's some logic inversion or something else. All right, all I'm going to tell it is, hey, we're getting some false inputs. It detects presses, but it's not good. And see what it suggests. Look at that. All right, the problem is thresholds are way too close to the noise floor from earlier logs. Idle noise was blah, 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 whatever. Let's see what it's changing. Polling every 20 milliseconds, calibration samples. Okay, well, let's keep it. Let's flash it. Short press. Okay, that worked. Now long press. Oh, look at that. Wow. No way. What? Look at that. It works. No way. Okay, so all I did was I switched the model and I basically told it, hey, it doesn't work. It's detecting false inputs and boom. This is starting to actually become a little scary because, wow. Ooh. Are we all going to become prompt engineers now? So I want to make sure this is very clear. Capacitive touch probably was the easiest thing that we could have done. Addressable LEDs, writing custom drivers with timing? I don't know. Let's see. Let's find out, because this is actually probably the most exciting part out of the whole thing. And then bringing up the piezo too, because we need frequencies and so forth. But addressable LEDs are going to be probably the toughest. We're going to write a driver. I'm telling it to write a simple driver where we give it an array of colors. So basically we're giving it 5 colors and we want those LEDs to light up literally in just that color. That's the goal. That's the point of this whole thing. And we're going to do a plan so that way we can see what it's going to be trying to do before it executes anything. Let's let it build. Let's see what happens. Okay, so it actually created a LED underscore strip underscore encoder. Great. Oh, and then there's a driver too. Oh, it's actually structuring things properly. Okay, so it did not compile. Let's just throw this error into here and see what happens. Look at that. It compiled. No way. All right. Wow. Is it actually going to... Oh my God. Watch this camera here. Let's make sure it's focused. No. All right. What? No way. This was easier than the capacitive touch. I can't believe... Are we all screwed? Look at this. This is absolutely crazy. Wow. Okay, well, let's bring up the piezo. Maybe this one will be harder. Wow. All right, so I'm literally going to tell it, hey, I want to play notes or sounds on the piezo. It is on IO48. Let's bring it up and see what happens. You know what? Let's actually let's play a jingle on startup. Let's see. Let's just give it even more scope than just simply bringing up the piezo. Let's see if it's able to do it. Will we compile right away? I don't have my hopes up. Every single time so far, something has been missing. No, we compiled. Wow. Okay. All right. I'm going to bring this up here to the microphone. So that way, I guess here, like this. I'm going to flash it. And let's see if this piezo is going to play a sound. I'm going to be quiet now. What was that? 5 minutes of work, basically, to bring up the piezo and play a jingle? Holy man. It's not a board that I just happened to buy or, AI knows. No, it's a custom-made board. I made this board. AI is definitely getting out of hand. Couple hours later, I was able to program in all the functionality into this board without touching a single line of code ever. I've got a Pomodoro mode, I've got a piano mode. I've got a Simon Says game, I've got a reaction game, and I even made this into a MIDI, meaning this is actually, it can act as a keyboard, which is crazy.
When was the last time you opened the window to ventilate your room? Seriously, was it today? Was it a year ago?
The way I see it is, look, people used to write code in assembly. Then we moved on to C. And now we are transitioning to prompt engineering. It's just another method of writing code. So whether you like AI or not, this would have normally have taken me weeks of work. And I was able to do it in a single day. And if you like this experiment and you want to see more stuff like this, hey, subscribe to the channel, and thank you for watching. I will see you in the next one.